With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. A block of 2 kg is pushed down an inclined plane of inclination 37 degree with a force of 20 Newton acting parallel to the inclined plane. It is found that the block moves on inclined plane with an acceleration of 10 Newton meter per second square, right? And if the block started from rest, find the work done first by the applied force in the first second. So just see here, it work done in first second is asked here, and work done by the weight in the first second, by the friction force acting on the block in the first second. So let's calculate the displacement of the block in first second. So it is given that the acceleration is this. So can we calculate the displacement in first second? That will be simply acceleration half into t square. So the acceleration is 10, t square is 1, so it will be 5 meter. So 5 meter is the displacement, right? Now work done. So work done for any force is simply this, right? Yeah, so simply this. So first let's calculate the work done by the applied force. So the work done by the applied force, so it is said that the force is acting parallel to the inclined plane. So the force is acting parallel to the inclined plane. So here the angle will be 0. So what I will write, F is cos 0 degree. So we'll get the force into 5 will be the work done. So the magnitude of the force is 20. So just put the value of force here. So this will be the work done by the force. Now second part is to calculate the work done by the weight of the block in first second, right? So in first second we already calculated the displacement. So just put this in the formula. So mg is the force here. Displacement is the same for both, for all. Now let's calculate the angle between the force applied and the displacement. So you can see this angle is theta, then this angle will be 90 minus theta. So what I will write, cos of 90 minus theta. So it will be sin theta, right? So just put the value. 20 is the weight force and S is 5 meter for all, and sin theta will be, sin 37 will be 3 by 5, right? So this 5 and this 5 will get cancelled. Now it is pushed down, right? So it is going in the direction of gravity. So the work will be positive and it will be 60 joule. Now work done by friction force, right? Okay, so work done by friction force, let's calculate the work done by the friction force. So it is given that it is pushed down an inclined plane of inclination, and the acceleration is also given. So let us first calculate the friction force. So the friction force will be equals to, so for friction force we need mu, which doesn't given in the question, right? So let's go from work energy theorem, where we will write this: work done by friction plus work done by gravity plus work done by the force is equals to change in kinetic energy, right? So change in kinetic energy is what? Half mv final square minus v initial square, right? Okay, square. So V initial is 0. It is given in the question starting from rest, right? So what will write, half m V final. So V final will be simply A times T, right? So A is 10 meter per second square. So in 1 second it will gain a velocity of 10 meter per second, right? So it will be 100. So the change in kinetic energy is 100. So can you calculate the friction force work? See here, this is 60 and this is 100. Yeah, so the work done by the force was 100 and the gravitational work was 60, and it is pushed down, so this will be plus 60, right? Okay, so just now put the value. this 100 and this 100 will get cancelled out, and you will get the friction force work is this, right? So from here you can conclude that the friction force would be equals to minus mg sine theta, right? Then only this work will come, right? Because you can see the work done by the gravity and the work done by the friction force is coming equal, right? So if you see here in the diagram, so if this in this direction the mg sine theta is acting, and in upper direction the friction force is acting, and here is the displacement. So we got the same work by the gravity and by the friction force, right? So the friction force magnitude will be equal to the mg sine theta, right? And the work done by the friction force is minus 60 Newton, and this is our answer of the three parts, right? The first part, the work done by the force is 100, and the second part is 60, and the work done by friction is minus 60. Simple. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.